Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today we are going to talk about how you can use step functions to create workflow of Redshift SQL Server statements. I created a similar video a couple of weeks back where I talked about how you can use event-based orchestration of Redshift SQL statement. That got a very good feedback, and a couple of viewers talked about creating such orchestration or workflow using step functions. And I heard similar requirements from some of my customers as well. So I thought, why not create a video where we talk about using step functions to orchestrate or workflow Redshift SQL statements. So let's get started. Just trying to understand the problem statement. Sometimes you have a requirement that you have a Redshift database and you want to actually run certain SQL statements in a sequence. So generally people who are very expert in SQL Server or who have limited programming knowledge or experience beyond SQL, like they don't understand how Python or PySpark part of the world work. They like to do their transformation in using SQL, and in that case, they have requirement where they have multiple SQL statements which they want to run in certain sequence, certain workflow in order to achieve their job. Now, you might say that, hey, I can do this thing using stored procedure. So I can create, you can say, a big stored procedure, which is simply going to call these SQL statements one by one. Well, yeah, that's definitely is a solution. No doubt about that, but this solution cannot handle complex scenarios. So let me take an example. Suppose you have a requirement where you have a workflow like this, that your SQL 1 starts, then SQL 2 and 3 should start in parallel, and once SQL 2 and 3 both finish, then only your SQL 4 should start. If you have a requirement like that, then your stored procedure cannot handle it. So if you have a linear execution, sequential execution, then yeah, stored procedure can take care of the complexity. But if you have little complex execution, then stored procedure cannot do it for you. And sometimes we have requirement where we want to actually schedule this whole workflow of SQLs, or we want to raise this whole workflow of SQLs based on certain events. And in that case, again, your stored procedure cannot do that because there is no way stored procedures can be hooked into an event or schedule. So the bottom line is that if you want to orchestrate your SQL statement in certain fashion, if you want to create a workflow of your SQL statement in certain fashion, your stored procedure can do the job, but only for very basic requirements. The moment the requirements come for higher complexity or integration using events or schedule, then you have to think of something else. And that's where the step functions come into the picture. So how do I use step functions to orchestrate my SQL statements in Redshift? There are two sets of technologies which come into the picture. The first set of technology or services which come into the picture is you can use AWS Lambda, which can use Redshift data API. Now I'm giving example here of Boto 3, which is Python based, but you can use any other programming language. And then you can use Lambda with Redshift data API to call a SQL statement. So bottom line is that if you have a SQL statement written into a Redshift database, that statement you can execute using Lambda function using Redshift data API. That's the first piece of the puzzle first piece of the solution you can use. And then comes your second piece of the solution, that is using AWS step function. And this then AWS step function can then simply create workflow using these Lambda functions to create any kind of complex orchestration you want to do. So Lambda functions and your step functions along with your Redshift data API can make this whole workflow run very nicely. Now, keep this in mind, and I want to really emphasize this point here. If you're trying to use AWS step functions, AWS step function does provides an out-of-box task for running the data API directly. That means you don't need to use Lambda function to call data API. There is an alternate solution where you can use data API task in the step functions to call the SQL statements directly. But those statements run only in a asynchronous, that task run in a asynchronous manner. If you want to do a synchronous execution, then you have to use some events mechanism that has its own like word in terms of how it works. So I have not talked about that approach today. I am taking an approach which is probably I can maximum or most of the people can use here is using Lambda function, because most of the guys know how to use Lambda function, and I'm using the Lambda function based approach to do this job. But keep this in mind, and if you're eager, you might want to explore on your own, or I might create some video some point of time where you can use your data API task directly in the step function to get the same kind of result I'm trying to achieve here using Lambda functions. Okay, so keep that option in mind. I want to tell about it so that you know there is one alternative, but today I'm focusing on Lambda function based approach. So let's get to know about some more details about this solution. The first thing and recommended solution is that if you are trying to orchestrate couple of SQL Server statements, couple of SQL statements in Redshift, then you might want to convert them into stored procedure. It is not mandatory, but it makes the whole configuration more readable, because if your SQL statement is like multi-line and complex, then configuring that into your step function might make the whole configuration look very unreadable, unmaintainable. So recommendation is that you try to convert each of the SQL statement into stored procedure, and by virtue of that, actually, when you configure your step functions, step functions are very readable, and you'll see that when we do the demo towards the end of the presentation. That also helps improve the performance, because with the stored procedures you get a better performance. So that's the starting point, easier fix. Now let's talk about the lambdas, because we are going to use Lambda functions to do the orchestration. So the first Lambda function you need to create is which is responsible for, and this is the heart of all this is the core Lambda function here in my opinion, that is the Lambda function which executes the SQL statement. And that Lambda function might look something like this. It's pretty simple in straightforward execution code. You can simply import Boto3. So I'm giving example of Python here, but you can use any other programming language here. So I'm simply importing Boto3. Then I'm creating a Redshift data client. And then I'm simply calling this execute statement where I'm passing my cluster ID, my database name, my secrets manager secret, and this secrets manager secret actually stores the login name and password for my Redshift cluster. So when this statement executes and it needs to authenticate against the Redshift cluster, it will simply use this secrets manager secret to fetch the credentials of the Redshift cluster and log in. So third configuration is your secrets manager, and then fourth one is your SQL statement itself, the SQL statement you want to run. So these four are the minimum requirement. I mean, there are a few more parameters, but if you want to work with Lambda, these four are good enough for you. So simply call this execute statement function method, and then that will simply execute the statement for you. Now keep this in mind, this is asynchronous statement. So when you call execute statement, it's not that execute statement is going to wait till the SQL statement finishes. No, it will simply start execution of the SQL statement and then will move on. The thread will move on. You will move on. So this is asynchronous in nature. So you are simply through execute statement calling a SQL statement, and the SQL statement is starting, and then you move on. Okay. Now, so that's how the function look like. So this is a very good thing. If so, like your execute statement is good enough if you want to create a workflow where there is no wait condition. Like you don't want to, like you want to run multiple SQL statement, but you don't want to wait for first statement to finish, then start second statement, and then wait for second statement to finish, then start third statement, and so on. So if you have workflow like this, where okay, your statement 1 runs, then 2 runs, then 3 runs, and they are pretty independent of each other, then you, of course, you can simply use this Lambda function into your orchestration, into your step functions, and you are good to create the workflow. You can do that. But so the one Lambda function is good enough if you don't want to wait for execution to finish. You simply want to orchestrate execution of your SQL statements. But what if you want to wait for execution to finish? That means you don't want to start this SQL statement unless this statement has finished. What if you don't want to start these two SQL statements unless this statement has finished? If you have that kind of workflow, then you need to do more. And in order to do more, you need to introduce one more Lambda function. And the second Lambda function is something which try to fetch the status of the statement execution. So when you created the execute Lambda function, it started the execution of your SQL statement, and then it moved on. Now you need another Lambda function which can try to find out what is the status of that execution, so that it can make it can help a workflow make decision whether that statement has finished execution or not. And if it has finished execution, then you move to the next SQL statement. If not, then you wait. You simply wait till the statement finishes the execution. So here the Lambda function again looks pretty straightforward. You have to import Boto3, like as a Python example here, create a client for Redshift data, and then simply use this describe statement function, passing statement ID to identify the statement, to know the status of the statement. So you can use these 3 lines of code to determine the status of the statement. And then the business logic is pretty straightforward. If my statement has finished the execution, then I move on to the next step. If not, then I wait till the execution finishes. So let's try to put these two together, these two Lambda functions together, to see how does my business logic for waiting look like. So if I want to wait to finish my SQL execution, how does that business logic look like? So first thing first, you run your execute Lambda function, which is responsible for starting the execution of the Lambda function. When it starts the execution, it gets a response back saying, this is my statement ID. So when you start a SQL statement execution, you get an identifier for that execution. There is an ID which identifies that particular execution. So that you get as an output. And that output goes as an input to the second Lambda function. So the first Lambda function started the statement, got a response back, where the most important thing to know is my statement ID, the GeoID, which identifies my SQL statement. And then I simply move on to the next Lambda function, which is going to check the status. So this Lambda function is going to use this statement ID to determine the status of the Lambda function. And it gives me an output like this, where I say, hey, this statement ID and this is the statement status. This could be it is finished, not finished, like in progress, failed. Yeah, so there are multiple status you can get. Like finished means you're done, and then there could be in progress, not started, started. There could be many other status. So this second Lambda function will simply give an output back saying that for this statement ID, my statement status is finished or something which is not finished. Then I need to put a decision box in my workflow to check if it is finished. If it is not finished, the statement ID, the statement status comes as not finished, I simply go back. I wait for a few more seconds. Let's give few more seconds to my my SQL statement to finish. Then go and check the status again. And if no, it has finished execution, you simply move to the next step. So that's how you can create a business logic using execute and status Lambda function to determine, to ensure that you will not move to the next SQL statement unless you have finished the execution of the current SQL statement. So this whole unit works as a this whole box shows a single execution boundary. Okay. Now I can then use this combination, these box actually, to create a workflow where the second SQL will not start unless the first one has finished. The third will not start till the second has finished. Or I can do this kind of branching and merging as well, where the things will the next SQL statement will always wait for the previous SQL statement to finish, and then only it will move. Now you can do mix and match as well. So it's not that, I mean, like there could be a scenario where you're saying, okay, my second statement will wait till my third statement has finished, but then third can start without waiting for second to finish. Or first can start, and the moment it starts, it can start another SQL statement, but then it start another SQL statement which then have a follow-up statement, but this statement has to finish till this one finishes. So you can do mix and match as well. So you have now a capability to run SQL statement without waiting for it to finish, or a SQL statement where you can wait for it to finish before you move next. Now, depending on your business requirement, depending on your business logic, now you can use combination of these functions or to build a business logic for your workflow. Now, let's try to see some of the details about these Lambda functions. I already showed you the code, but I want to show how the input and output look like one more time. So for instance, your execute Lambda function might look like something like this. And again, I'm using a Python example. So you have a Lambda function where you simply importing JSON and Boto3, then you create a Redshift client, you provide your cluster ID, database, and secret. Now in this example, I have hard coded the cluster ID, DB, and secrets, but what you can do is that you can put that into the environment variable of the Lambda function, and that way you are not hard coding. Then and that's a recommended way, by the way. That's the recommended way. Then I simply get my SQL statement from the events, from the input. So this Lambda function will expect that you pass it input something like this, where you simply have a key value pair where SQL is the key and the value is the SQL statement, which actually you want to execute. And you can see here I have simply used call and then stored procedure name. Now, and this is the example why I told you that if you're trying to use a SQL statement, try to use a stored procedure, because think about a SQL statement which is very large over here. Then it will be really challenging and not readable, okay? Because your SQL statement sometimes could be multi-line actually, yeah? So converting that into stored procedure always helps, both from the readability, maintainability point of view, and also from performance point of view. So this Lambda function expect an input like this, and then it simply will extract the SQL statement from the input, and then rest of the code, it is going to simply call the execute statement function. In the response, it gets gets the statement ID, and that statement ID is simply throw out as an output. So your output comes out like this Lambda function has successfully completed, and this is my statement ID. And this output is important because if you want to use the second Lambda function to wait for this statement to finish, then this statement ID will be used by the second Lambda function. So having understood how execute Lambda function works, let's move on to the second one. How does my status Lambda function works? Again, I have showed you the code, but I want to show you one more time here with input and output. So in the second Lambda function, we have got again import JSON and Boto3. Here is my Lambda function. Again, it's a Python example. You are creating a Redshift data client. Then I am getting my statement ID from the event. So this Lambda function is expecting an input like this, where I provide statement ID here, and this statement ID, if you look at this is the output of the first Lambda function. So what we are trying to do in my workflow is that take the output of the execute Lambda function and simply put as an input in my status Lambda function. So this input has got statement ID, so I simply fetch the statement ID, use the describe method to find out my status of my statement execution, and then I create a response where we put this statement ID has got the following status, so you get a status like this. So you get status code of the Lambda function, statement ID, and then statement status, which could be finished or something which is not finished, like in progress or failed. So you create output like that, and then this output then can be used to make a decision by step functions to determine whether I need to wait for this statement to finish or I can move on to the next statement. And I'm going to show you demo as well, guys, so you will see the whole thing working very soon. So how do I hook to the event? So okay, fine. So now you understand how do you create Lambda function, how do you create step functions, and how do I configure everything together. Now one of the other requirement which come across is when you want to hook to the event or schedule, and that's where actually step function can become very handy because step function can look into schedule or events coming from CloudWatch logs, or it can also see schedule or events coming from Event Bridge. And by virtue of that, actually you can integrate step functions workflow with any of the events within AWS services to execute your workflow based on event or schedule. And so yeah, and that's pretty much out-of-box feature of step function, where it can actually it can be used to trigger based on schedule or events of the from the CloudWatch log or Event Bridge. Okay, having covered this part, let's see how does my Lambda function, how does my step function look like. So your step function can look something like this. This is something we are going to build as well today. So you execute the first statement using a Lambda function, then you see the status of the Lambda function, then you use a choice box, a choice state within step function to determine whether my statement has finished or not. If statement has not finished, then you wait for a couple of minutes, couple of seconds, and then you go back to check the status again, and this loop will keep running till my statement has finished the execution. The moment the statement has finished the execution, you move on to the next statement where you execute the statement, again check the status of the statement, and then use the choice state to keep looping into this particular path till your second statement has finished the execution. And once a second one has finished the execution, you can start the third execution. And third one, I'm like, if this is the last one, to be honest, you don't need to wait for the last one because there is nothing after this. So let this statement finish and then it ends your workflow. So that's pretty much how your configuration will look like. Again, I have showed you example from a linear execution point of view, but you got the idea. If you are using step function, you can use this kind of combination of Lambda function and choice state to create any kind of complex workflow. Okay, so time for the demo. So what we are going to do today is that we have we have a Redshift cluster. In that Redshift cluster, we have got a couple of tables. So there is an orders table, pretty simple table. And I'm creating order summary, product summary, and product quantity summary. These three tables out of my orders table. And these three tables are populated using three stored procedures. So fill order summary will populate the order summary. Similarly, fill product summary and fill product quantity summary will populate product summary and product quantity summary. And what I want to do is I want to run these three stored procedure in the following sequence. And your second statement will not start before the first statement finishes, and your third statement will not start unless your second statement has finished. So this is how I want to create the workflow. And whatever I show in the demo, I have already provided the code and samples and everything into a zip in a zip file, and link to the zip file has been provided in the description box below. So if you want to work on your own after watching the demo, you can use that as a resource to start with. So let's jump on to the demo. So what we have got, so few things are already configured for my my demo. So I already have got a Redshift cluster in place, which is already up and running. So that's a good thing. Now what I have done is that I have connected to that Redshift cluster using Redshift Query Editor version 2. I love this version, by the way. And you can see here I have got 4 tables over here. My orders table has got 4 columns, order number, product code, quantity ordered, price each, and I think there are a few more columns over there. Yeah, amount as well. And then I have got order summary table, which shows you total sales per order. So it simply shows sum of the sales per order number. And then similarly, I have got product summary, which shows total sales per product code. And then the third one, product quantity summary, will show total quantity per product code. So pretty straightforward SQL statement. I try to keep it very simple for demo purpose. I have created 3 stored procedure over here. So you can see 3 stored procedures. And if I open one of the stored procedure, I think I need to do like this. It's a stored procedure, which is simply first cleaning up the order summary. Again, I'm just doing it, but in your business logic, you might not have to delete the previous records if you're trying to use some business logic to process only new data. Then you have simply populating the order summary, where I'm selecting my order number and sum of the amount from the orders grouped by the order number. And similar business logic has been used into my products quantity and product summary as well. And again, all this code has been provided in the description in the zip file, and the zip file is there's a link for the zip file in description box below. Now what I'm going to do, I'm going to now see the count of these 3 tables to see if these tables are empty at this point of time. So I'm simply running this SQL statement now, and I can see here that all the 3 tables are empty. That means there are no records in those tables at this point of time. So that's my work which has been done into the Redshift cluster. Now I go to my Lambda function. My first Lambda function is execute function, execute stored procedure function. Okay, I could have kept the name simple. Sorry for that, guys. And then here is the code. And right now, as I mentioned earlier, I want to emphasize again, I have hard coded these cluster ID and database and secrets name, but ideally you should be using environment variable. I try to keep it simple so that it is more readable, and I'm lazy as well. I mean both. Yeah. So keep these variables, keep these configuration variables into environment variable. Don't hard code like I have done here. It's bad on me. So it's the same code I showed you earlier, nothing new. And then I have got another Lambda function, which is the status Lambda function, and he says get Redshift stored procedure status function. Again, I could have kept the name simple. And I'm simply using the same code earlier, as I showed earlier, to get the status of the Lambda function. So my Lambda functions are ready, my Redshift clusters are ready, my stored procedures are ready, my tables are empty. So it looks like ground is all set and I can start configuration of my step function. So I've already actually configured one example step function in case something goes wrong today in the demo, then I can simply show you this step function and I run it. But let's create a new state machine workflow. And it's a standard workflow. Next. And then yeah, leave it here, and then I simply first thing I do is that I'm going to so there are 3 SQL statements there. So first one is I'm going to invoke the first Lambda function, and I will call it, say, exec statement 1. So it has execute statement 1. And which Lambda function I want to use for that, and my Lambda function is actually, if you look at that, exec stored procedure, and what input I want to give. So I need to tell this Lambda function which statement to run, and for that I'm going to simply enter a payload here, and my payload is pretty simple. My payload is as I described in the presentation as well. This is a SQL, and the SQL is call my order summary stored procedure. So my first configuration is ready. Now I need to after that I need to actually get the status of the Lambda function. For that I drag and drop the second statement, second Lambda function step here. I go here on the top, and I simply call it, say, status exec status statement 1. Now in this case I need to use the second Lambda function, so I'm going to use this particular Lambda function, and then in this case I simply going to use the, so what is the output comes out of this, I'm going to put as an input here, so I don't need to do anything with the payload here. So I'm all good here. Let me reduce this a bit here, okay, so I get more space. And then can I do this here? No, okay, okay, fair enough. So now my second Lambda function is created. Now I need to put a choice statement here. So I'm going to simply put a choice statement here. And then in the choice state, actually, I have to create the rule and select the execution. So first thing first, I want to say that if my Lambda my default execution is simply move on to the next step, and the next step will be, actually, let me quickly configure this. So my default statement is that simply exec statement statement 2, and my statement 2 I can execute using my exec function, and I want to give an input for this, because here my SQL statement has changed. So I can give my next payload here saying that, okay, this one will execute fill product summary stored procedure. So this is my default behavior, and here this one, rule 1, I'm going to use to check the wait status. So I go to my choices here, and I click on my rule 1, and my rule 1 says that let's edit it, and here I want to add a condition, and my condition is that if not, and then from my previous input I'm getting a key with value from using a key statement status. If my statement status is not equal to string constant, and that constant is finished. Okay, so pretty straightforward. I'm saying that if my statement status from my status output, status Lambda function output, is not equal to finished. So if it is not finished, okay, if not finished, then I want to go to the wait condition. So for that, what I will do, I will go to the flow here. I will take out this wait here. Let's drag and drop wait here. Let's wait for 2 seconds. It's very straightforward, so should not take much time. Wait. So I'm saying, okay, here, come again. I'm simply saying if this statement is not true, simply go for the if statement status is not equal to finish, go for the wait state. And from wait state, I don't want to go to the end, but I want to go to the status execution 1. So here we go. Let me show it here. Yeah, it's not okay. I can probably reduce my resolution a bit. Yeah, there we go. So you can see here my statement once executed, statement 1 status, then I put a choice. If my choice condition says that it is not finished, go for the wait, where I wait for a couple of seconds. I wait for a couple of seconds, 2 seconds in fact, and then I go back to check the status again. And if not, if this wait condition, there is no, if it has finished, then it goes to default route, and default route is simply execute statement number 2. Now at this point of time, I can now check the status of the statement number 2. So I can drag and drop another Lambda function over here and call it, this is status statement 2. And then, okay, let's make it bigger here. And I select my Lambda function, which in this case is get status. And then I simply going to use state input over here. Okay, so simply the output of this one will go as an input of this one. And then at this point of time, again, I can put my next check here. And next check is again using the choice. And in this case, my default flow is pretty straightforward. My default flow will simply go and execute the statement number 3. So let me configure that one first. So my default one will go here, and this one will say exec statement 3, and this one will simply use my exec Lambda function here, and then I can give a payload for this, and my payload is my third SQL statement. So my payload is pretty straightforward, my third SQL statement. Yeah, product quantity summary. And this can go to the end. After this, I don't need to check anything because this is the last statement. But here I need to wait, handle wait condition. So I put a wait here again. So I simply drag and drop wait over here. And again, I want to wait for 2 seconds. And let me modify the choice here. So if I go to choice and I check the rule for rule 1 condition here. Here again, I want to add a condition saying that if not, and look into my statement status. If this is equal to string constant, and that is finished, save condition. So again, I'm saying if not statement status equal to finish, then in this case next state is you go to the wait 1, and from wait 1 I don't want to go to the end, but I want to go back to my status 2. So I think I can remove this part here. I can minimize this part here. So my business logic is pretty much developed here. So I am going to run my statement first, which is simply taking my first payload and running the statement 1. Then I check the status of the statement 1. Then I make a choice here whether to wait or go to the next one. Then I go to the next one where I run the second one. And then, I want to check one thing. Second one. Then I check the status of the second one, and again I go for the wait condition. If need comes, I'm waiting for 2 seconds here in this case again. If everything goes fine, I go to the third statement where I simply run my third SQL statement. So this looks good. So my workflow is configured here using 3 SQL statements. I can go to the next now. Here it shows you everything, yeah, in a JSON document. And this JSON I have provided also as an example, so you can use it if you want, like as a starting point. Go to the next. Here I am going to call it my SQL workflow. Okay, and I'm going to simply create a new execution role. So I could have created a new like existing role, but I said okay, let step function do this job for me, and I keep everything by default and create this state machine workflow. So now what it is going to do, it's going to create a state machine workflow for me, and this state machine workflow is now created here. So if I go to my state machines, I can see there are two workflows which are created. Now I want to select this workflow which I just created and I want to run it. So I simply, I think I need to go inside. I go inside and say I want to start the execution. It's asking for some default payload. So a few things you can do is that if for instance, you want to pass some more global parameters, you can pass over here. But in my example, I kept it pretty straightforward. So I don't need any input. It's optional anyway. So I start the execution. And then I wait for my execution to finish. So my statement has, my function has, sorry, my workflow has started. And if everything is fine, it should finish. Yeah, and here we go. So it has just finished the execution. So it went well in first go. It did not go for wait condition at all actually, and then in the second one it went for wait condition. It has to wait for some time, and then the third statement executes it. So my workflow has executed. Now if I go back to my Redshift cluster query editor and run this count query again, which was 0 earlier, now I should see some results. So you can see here that I have got my product quantity summary, some 11 records. My results had got some 11 records again, and the third one has got the 4 record. I can see that through like a preview query as well. So I simply say select statement and I run it, and you can see the data here as well. So that shows how you can use how you can orchestrate SQL statement in AWS step function to create orchestration like this. This again, I'll tell you, I created a simple orchestration, but you understand how this whole thing works, and you can create any kind of complex orchestration as long as that kind of orchestration is supported by step function. You have no limits. Yeah. So that was all for today, guys. Hope you liked the video, and if you like the video, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, whether it is for new content or any of the correction you want to make, and most important and most comment I get is discussion about design option, architecture options, solutions. I love to respond to those kind of query. Please write those comments on my YouTube channel, and I will make sure I respond to your comments soonest possible. I promise to come back again in a week's time with another such video and tutorial. In the meantime, please stay safe and have a nice day. Bye-bye.